I said in an email that I'm going to try and do the Zoom a little bit differently this week since a lot of people don't like the breakout rooms thing. Um, I am going to do some examples for us all, just similar to the ones in the video, but just more examples. And I would encourage you all to follow along and feel free to interrupt with questions. Before that, I got an announcement. I sent an email concerning this. I am giving a presentation, a talk about voting on Thursday at 5 p.m. Thursday this week. A talk about voting. It's about the mathematics of voting, and it's on Zoom. And I emailed a link sometime maybe this past weekend. If you go, you will get FYE credit, which I know might interest some of you. It's the Inspire kind of FYE stuff. This is a talk about the mathematics of voting. It's not really a talk about this election that's going on right now. It is about voting and elections in general. So I will not be offering you my political hot takes. If you're interested in my political hot takes, you can ask me, and I will feel free to tell you all of my political opinions. But that's not what this talk is all about. Thursday night, 5 p.m. Tell your friends, invite your grandmas. It should be fun and exciting for everybody. Anybody have any questions about that? Check it out. It's going to be great. Okay, let's related. Yeah, is that a question? No, I thought I heard a question. All right. Related to that is, unfortunately, I have not graded your tests. It's related to that because I've been trying to get ready for this thing, and I have another thing going on this week, which has taken up a lot of my time too. So I'm sorry I haven't graded the tests yet, and to be honest, they probably will not get done until next week. So I apologize for the delay on those. Any questions about any of that business? All right, let's get down to it then. So I want to do 2 examples from this assignment. The assignment is, or these problems actually are quite involved. They're not super hard. I mean, some are hard, but they will take you a long time to do each individual problem. So I'm just going to do 2 of them, if that sounds all right. Let's get it going. I'm going to do 2 problems that I found in the book. So the first one is section 5.2, number 17. All right. I don't know if you care what it is in the book. These are from the book, but it's not, this one is not on the homework. The problem is, hold on a moment. Okay, it's going to be f of x equals -4/3 x cubed minus 21/2 x squared. Sorry, I should have written this down before. Minus 5x plus 8. All right, this is the problem in the book. Your job is to find the relative extrema. That means you want to find relative minimum and maximum points. So on a graph, if the graph looks like that, this right here is a relative maximum, and this right here is a relative minimum. These are points where the y values are greater than all the nearby y values, or lesser than all the nearby y values. In a maximum point, the y value at that point is greater than the nearby y values. And then this is a minimum, lesser than the nearby y values. Okay? On a picture, you just look at it and you can identify easily what those points are. But if I tell you the equation for something, it's quite a bit more involved. Anyway, come on now. The procedure is the same, really, as the procedure for doing the increasing decreasing thing, which you did last week. It's the same process. It's just a matter of how you interpret the chart at the end. So let's try to do this one. We begin by finding the critical numbers. That is where the derivative equals 0. So you should start by taking the derivative. What do you get? I get minus 4x squared. You bring this up here, right? You bring the 3 down, it cancels the 3 denominator. Here, you bring the 2 down, it cancels the 2 denominator. I get minus 21x minus 5. That's the derivative. And now we want to simplify this as much as we can. Actually, this is an example of kind of a hard factoring. I am going to, first of all, you can pull a minus sign out of everything, which doesn't make a big difference, but makes me feel a little bit better. 4x squared plus 21x plus 5, right? I took the minus sign out of everything there. And now I gotta factor this. So it's going to be minus on the outside, factor it into 2 groups like that. This is kind of a tricky factoring because we're gonna have coefficients in front of the x's, right? These coefficients in front of the x's need to multiply to be 4. And then as usual, the 2 constants in the end, they're both plus, will multiply to be 5. So the constants on the end, they have to be 1 and 5, but the other 2, they could be 4 and 1 or 2 and 2, and you have to just work out how can you combine them in order to get 21 in the middle. The answer is if you do 4 times 5, that would be 20, and then a 1 times a 1 would be 1, and that would make 21. So the way you want to factor this would be like this, with a 4 there and the 5 there, and then a 1 here and a 1 here. All right, this is a hard factoring. I don't want to get bogged down in the factoring business, but this is how you factor that. That is the derivative. Let me write that again and sort of put it in a box. F prime of x is minus 4x plus 1, x plus 5. All right? Any questions so far? Sorry, I keep getting these dings, but I can't turn my sound off without losing the Zoom sound, so I think we're gonna have to deal with it. Sorry about that. At least you can't see my dings, my important, intensely private texts. Okay, we are looking at the derivative right there. I distracted myself telling you about my intensely private texts. All right, next step is to find the critical numbers. That would be set the derivative equal to 0. And also say where the derivative does not exist. So, setting the derivative equal to 0 looks like minus 4x plus 1, x plus 5 equals 0, right? And now we solve for x. The minus sign really doesn't matter at all. We can divide a minus sign on both sides and it will just go away. It's the same as 4x plus 1, x plus 5 equals 0, right? The minus sign doesn't matter because you can multiply both sides by minus 1. Or divide both sides by minus 1. Now we have 2 things multiplied to be 0. That means either the first is 0 or the second is 0. So I go 4x plus 1 equals 0. X plus 5 equals 0. And now we solve separately. The second one will be x equal minus 5. The first one, you subtract the 1. I get 4x equal minus 1. X equal minus 1/4. And these are my 2 critical numbers, right? So I'm going to make a chart which has those numbers labeled on it. I'm going to put them in numerical order. Negative 5 is less, and then negative 1/4 goes there. All right? And these are 2 numbers where the derivative is 0. Everybody with it so far? Anybody got any questions at this point? Everybody seems to be with it. I hear no questions. We also must check to see when the derivative does not exist, which in this problem doesn't matter. So you should also check f prime does not exist. I'm just going to say NA. In this step, you should be looking for points at which the denominator is 0 or something like that. That's what could make the derivative fail to exist. But for this function, there is no denominator. No funny business at all, so there's nowhere that the derivative does not exist. All right, anyway, we have our chart here. We need to choose values in the various intervals and then plug them into the derivative. Let me bring my derivative down here also. This is what we're going to plug into. Wasn't that awesome? I'm going to choose values in between the -5 and the -1/4 and plug them into the derivative. So on the left of -5, let's choose -6. F prime of -6 is, we plug into the thing in the box, minus 4 times -6 plus 1, and then -6 plus 5. And now, as usual, we don't care precisely what the number is. We just want to know what the sign is. Is it positive or negative? Now, if you look at these, I have minus, of course, at the beginning. 4 times -6 plus 1, that is negative, right? 4 times -6 is -24, right? Plus 1, -23. Anyway, negative, right? And then this last thing is also negative. So I have here 3 negatives being multiplied together. The answer is negative. So right up here, I'm going to say it is negative in that region to the left of -5. The derivative is negative. All right. How about in between -5 and -1/4? Let's choose -1. I have, again, plugging into the box, a minus to begin with, and then 4 times -1 plus 1, and at the end, -1 plus 5. What are these? Again, I don't care about the numbers so much, but I care, are they positive or negative? Well, I have a negative here. This one, 4 times -1 is -4, plus 1 is -3. That's negative. And then finally here, -1 plus 5, that's positive, right? So here I have a negative times a negative times a positive, which results in a positive. So I get positive in the middle interval. And then finally, to the right of -1/4, let's choose 0. I always like to choose 0 when I can. Minus 4 times 0 plus 1, and then 0 plus 5. And what's that? This is a minus and then a plus and then a plus, which makes a minus, so it's negative over there. All right, we're done with the chart. And now is when we just report the answer, right? It's not difficult to say what the answer is. You just have to remember how to interpret the chart. I look at the chart over here. Around -5, I'm going to say x equal -5 is a relative max or min. You have to remember the rule. If you look at the signs on either side of the -5, what I see is a negative followed by a positive. That means the shape of the graph goes down in this region and then it goes back up in this region, which means that point in the middle must be at the bottom of the hill. So it is a relative minimum. All right, and x equal -1/4. Again, we look at the signs here. It says positive followed by negative. That means that point must be at the top of the heap. This is a relative maximum, and that's how we do it. Are there any questions about that one? No questions from anybody. All right, great. If you look these answers up in the back of the book, you may notice they also tell you the y values. I don't so much care about the y values. To find the y value, plug the x back into the original formula, which you could do if you want to. I don't care about that though. All right, just give me the x values of the relative minimum and the relative maximum. Okay, that was the first one. I said I wanted to do 2 of them. That was the first one. Any lingering concerns about that one? All right, let's do the other one. So the other one I wanted to do, that was an example of an easy one, although that one, the factoring was a little weird. So I wouldn't say that was completely easy, but fairly easy as far as these things go. Next, I want to do number 29 in the book. This is a harder one. It says f of x equal x squared e to the x minus 3. All right. What makes this one harder is it's got the e to the x in it, which ends up complicating things a little bit. It's not so bad, but it is slightly more complicated. All right. Don't worry about it yet. As before, we begin by taking the derivative. So I go f prime of x equals. What's your strategy here? First of all, don't be fooled by this minus 3. Some people will be tempted to interpret this as if it said that. X squared times x minus 3, where the minus 3 is kind of grouped with the e to the x. That is not what it says. That's not what they wrote. They didn't write those parentheses. It means the 3 is really all alone by itself. It has nothing to do with the other part. So when I take the derivative, that 3 is just going to go away, right? We have two separate things here, and we take the derivatives separately and add the two derivatives together. And that 3 is going to become 0 when I take the derivative. So this ends up being, plus 0 or minus 0, all right? What about the first part? X squared times e to the x. Because of that times right there, you got to do the product rule. So the product rule says the first part, x squared, times derivative of the second part is e to the x. Remember, the derivative of e to the x is e to the x. And then plus, second part is e to the x times derivative of x squared is 2x, like so. All right? This is my derivative. The plus 0 at the end, of course, doesn't do anything. So this is x squared e to the x plus, can I just rearrange this? 2x times e to the x. I just change the order around. All right, what can we do to simplify that? I want to simplify as much as possible because we're going to have to keep on using this function throughout the rest of the problem. This is very similar to ones that you did for increasing and decreasing which had e's in them. In order to simplify, you should factor out the e to the x. So I say e to the x, and then what remains on the inside would be x squared plus 2x, right? That thing had two things added together. Each of them had e to the x as a factor, so I take the e to the x out, and what remains is the two other things, x squared and the 2x. And in fact, that x squared plus 2x can factor. I can pull x out of that. So this is e to the x times what remains, x plus 2, right? This is f prime of x. That is as simple as this thing is going to get. All right. Any questions about that so far? Actually, to the extent I said this one was a little bit harder, that was the hard stuff. Just knowing how to deal with the e to the x. From now on, it's going to be not any harder than the other one. Maybe a little easier from now on. Again, we are going to set the derivative equal to 0, and also say when the derivative fails to exist. F prime equals 0. What is that? I set this equal to 0. E to the x times x plus 2 equals 0. This is a bunch of stuff multiplied together to give me 0, which means I can set each thing equal to 0. E to the x equals 0. X equals 0. X plus 2 equals 0. And then, okay, x equals 0, I guess that is a critical number. X plus 2 I can solve. I get x equal minus 2. That's a critical number. What about e to the x equals 0? This one, if you recall from the increasing decreasing stuff, we had examples like this. E to the x is always positive and never 0. Let me just write that down. E to the x is always positive, never 0, which means e to the x, that part gives me no more critical numbers. All right, so no critical numbers from this part, e to the x equals 0. You get there are no x values which make e to the x equals 0 because e to the x is always positive, never 0. All right, what about f prime does not exist? Well, remember, for such a thing, you are looking at the derivative and trying to look at when is the denominator equal to 0 or something like that. There are no denominators here, and so again, this is a NA. This will only really come up when you have a fraction in the derivative, and we don't in this example. So that's a big NA from me. All right, I think we can make the chart then. I make the chart, label my critical numbers, which are 0 and 2, put them in order, all right? And now I'm going to plug into the derivative many times. Can I put that down here? I got a little too much. What? All right. Let's see if we can plug in on either side of those numbers. To the left of 0, I'm going to use -1. F prime of -1 is e to the -1 times -1 times -1 plus 2. How about positives or negatives? That's what you got to do here. Are these positive or negative? What about e to the -1? Is that positive or negative? What do you think? Somebody shout it out. Anybody out there? Is e to the -1, is that positive or negative?
Positive. Positive.
It is positive. They're saying positive. Thank you. It's because of what I just said. E to the x is always positive, never 0. Even when the exponent is negative, e to whatever, it's still positive. Remember, e to the -1 really means 1 over e to the 1, and that's positive. Anyway, this is positive times, of course, the next thing is negative, being -1, and then the last thing there is positive, right? -1 plus 2 is positive. So the answer here is a negative, right? I didn't put it on my chart this time. I usually put f prime is 0 here and 0 here. That's not so important.
On the chart, isn't it -2 and 0, not 0 and positive 2?
What? Oh, it is. Yes, thank you. I don't know who said that, but you are so right. I'm so ashamed. Here's how we do it. It should be -2 and 0. Yeah, thank you for that. So you better put -2 on the left side and 0. And the one I just did, choosing x equal -1, is actually in the middle on this new picture. Thank you for that. That was totally wrong what I did before. How you like me now? Good. I don't know who said that before. All right. Usually when I say how you like me now, I don't actually expect someone to answer me. Let's choose some other values. How about to the left of -2? I'm going to choose, say, -3. F prime of -3. What do we get? E to the -3 times -3 times -3 plus 2. Remember, I'm plugging into the formula in the box. And what are those? E to the -3 is positive because e to any power is always positive. -3, of course, is negative. And then finally, -3 plus 2, that is negative, right? That's negative. -3 plus 2 is -1. So I got a minus and 2 negatives. That makes a positive. So over here is positive to the left of -2. All right, and finally, we're almost done here. What's your favorite number to the right of 0? I would say 1. Plug that in. E to the 1 times 1 times 1 plus 2. And these are all positive. Positive, positive, positive. So I get positive up here. All right. And now finally, to get my answer, I just need to look at the chart there. I say x equal -2 is a relative maximum or minimum. It depends. You look at the picture here. I see plus followed by minus. It's going up and then back down, which means that point is a maximum. So x -2 is a relative maximum. X equal 0 is a relative. On the chart near 0, I see down and then back up, right? Which means that is a minimum. And that's all I got to say about that. That's how we do it. Any questions about that? I just dropped my pen. I hope I didn't mess it up again. I feel pretty good about that, though. All right. That is all that I wanted to do for you all. Are there any questions about these ones that I did, or perhaps one that I didn't do that somebody wanted to talk about all together?
I just had a quick question about an example like 4x cubed instead of it being squared.
Yes.
Just how to factor that one.
So are you perhaps looking at
19 on lecture 18.
Yeah, number 19. Okay, yeah, we could just talk about the beginning of that one. So this one actually is on the homework. X to the 4 minus 18x squared minus 4. All right, this is f of x, not f prime. To find the derivative, are you still there? Can you tell me what you got for the derivative?
Yeah, I got 4 and then x cubed minus 9. x cubed and then 9 are together in parentheses.
Oh, I see. Okay, so you skipped a few steps, what you just said, right?
Oh yeah.
Yeah, so, sorry.
Oh yeah. 4x cubed minus 36.
Yeah, 4x cubed minus 36x. I think maybe that's your problem. Did you forget the x there? That x is important. So from here, you can factor out of both of those. You can factor 4x out, and what remains is x squared minus 9.
Yeah, that makes more sense.
Yeah, if you got a x cubed minus 9, then it'd be impossible at that point. So